Hi everybody, welcome to chapter 9, which once again deals with fractions. We just got done with chapter 8, which taught us introductory lessons into fractions. Now we're going to put that knowledge to use to help us with chapter 9. Today I'm going to do two lessons combined into one video. I'm going to do lessons 9-1 and 9-3. Both of them deal with adding fractions with like denominators. 9-1 is going to show us how to use models or pictures to add, and 9-3 is just going to be the algorithm to add. In 9-3, however, we're going to talk about something called mixed numbers. I've made a reference to this before from chapter 8, but today we're going to talk about it a little bit more in-depthly. So let's get started. Up top, I have a rectangle broken into 6 pieces. I'm going to do an addition problem using this model. I'm going to say 1/6 of my puzzle was completed on Sunday. So I'm going to shade in 1/6, 1 out of 6 total pieces. Then on Monday I was able to complete another 3/6 of my puzzle. So I'm going to add to the completion 3/6. 1, 2, 3. So my question is, how much of the puzzle have I completed so far? Well, again, on Sunday I did 1/6. On Monday I added another 3/6 to the puzzle. And my final answer is going to be 4/6. Now notice, I didn't change the way my picture was broken up. It's still broken into 6 equal pieces. All I did was shade in 6th to show how much of the puzzle I completed on what day. Let's take the second example here. I have a pizza, and it's broken into 8ths. So, we'll say for lunch, I ate 2/8 of the pizza. 1/8, 2/8. So for lunch, in orange, I ate 2/8 of the pizza. Easy enough. Then for dinner, I ate another 3/8 of the pizza. So I'm going to add 3/8 to it. Notice I didn't change how much pizza I had. All I'm doing is shading in how much I've eaten. So 1/8, 2/8, 3/8. Now friends, notice I didn't shade in right next to each other purposefully to illustrate for you that your pictures do not need to be exactly next to each other, your shading. Okay? Most people, myself included, like when it is, but you can pick any of the 8ths as long as you do 2 for the first set and 3 for the second set. So I started with the whole pizza. The shading represents how much I've eaten. So I ate 2/8 plus another 3/8. How much pizza have I eaten? Well, I've eaten a total of 1, 2, 3, 4, 5. I've eaten a total of 5/8 of the pizza. Notice I didn't cut my pizza into 16 pieces. A common misconception is adding your denominators. You don't want to do that. Your pizza stayed as 8ths, and you want to keep your denominators the same when you add or subtract fractions. The last one I'm going to illustrate using a number line. My number line is broken into 7 equal pieces. And I'm going to start with 1/7. So that will be this right here. And to my 1/7, I'm going to add another 3/7 plus 3/7, 1/7, 2/7, 3/7 for a final answer of 4/7. Well, how can I check myself on my number line? It's fairly simple. I can label it. 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, and 1 whole equals 7/7. So that's a little illustration of section 9-1. It uses models or pictures to help you add fractions with like denominators. 9-3, however, is just using numbers. But we are going to use some pictures to help us figure out some improper fractions. So very quickly, 9-3, 3/5 plus 1/5 equals would be an example problem. When you add or subtract fractions with like denominators, you do whatever operation is involved to the numerator and you keep your denominator the same. In this case, 3 plus 1 is 4, and my denominator does not change. It stays broken into fifths. Easy enough. Another example, 8/13 plus 3/13. Again, I'm going to add my numerators together and keep my denominators the same. So 8 plus 3, I'm going to get a new numerator of 11, and my denominator stays as a 13. Easy enough. So the question comes, what happens when I eat 3/4 of ice cream on one day, and the next day I eat another 3/4? So I just went over how we add our numerators together and we keep our denominators the same. Well, if I follow that rule, I have 3 plus 3, which equals 6. My denominator stays as a 4. That's what we call an improper fraction. I alluded to that in chapter 8, but this is called an improper fraction because my numerator is larger than my denominator. Most of the time, I don't like to keep my fractions as improper. I like to turn them into proper fractions. So to do that today, we're going to draw some pictures to help us. I need to color in 6/4. Well, how can I do that? We draw a square, cut it into 4 equal pieces. I need to color in 6 of those pieces. Well, let's see what we can do. Here's 3/4, 1/4, 2/4, 3/4. So we'll put a green dot for this section. Plus another 3/4, which is going to be an orange. Well, I only have 1/4 here. So what I need to do is draw a second square and break it into 4 equal pieces. So I've colored in 1/4 already. Here's 2/4. Here's 3/4. So this illustrates how I can turn an improper fraction into what we call a mixed number. What I have here is one whole thing colored in. In my second figure, I have 1, 2 out of 4, or 2/4 colored in. So my new mixed number is written as 1 whole, which is a large 1, and then my fraction is going to go right next to it. I'm mixing a fraction with a whole number. So it's 1 from the whole and 2/4 from my second figure that's not completely colored in. Let me do one more example for you using the mixed numbers, using the pictures as illustrations to help you see how to do it. So we'll do the problems. Let's do 2/3 plus 2/3. If I were to just solve this problem, I would come up with an improper fraction of 2 plus 2 is 4, and my denominator stays the same. I cannot leave my fraction as an improper fraction. I need to write it as a mixed number. So what I'm going to do is do an illustration to help me figure that out for now. I'm going to break my figure into 3 equal pieces, and I'll use orange here, and I'm going to color in 2/3. 1/3, 2/3. Okay? To that, I'm going to add another 2/3. And I'll do that in blue. Well, I can only shade 1/3 on this figure, so I need to draw a second figure and break it into 3 equal pieces. So I've already shaded in 1/3. I need to shade in another third. 1/3, 2/3. So what I have here, again, is one whole figure colored in. This entire figure is colored. One whole thing is colored in. And how much of my second one is? Well, 1/3 of it is. So 4/3, written as a mixed number, remember I'm going to mix a whole number with a fraction, is going to be a big 1 to illustrate my whole, and then 1/3 to illustrate my fraction. I hope this helps you a little bit with your studying and your homework for sections 9-1 and 9-3. Thanks for watching.